Whoa, welcome guys. So in this video, we are trying to describe some final property of the Legendre polynomial. So be sure to subscribe to my channel, and I hope to see you guys in my channel. And okay. So the first is that the special values. So first thing I want to talk about is the special values of the Legendre polynomial. Okay, so basically we will answer the following three questions. The first one is that p of 0, p of 1, p of -1, and p of 0. I should say pn of it. Okay, so let's quickly prove. So remember guys that we have this, right? We have this pn to xtn. Okay, so the first thing is if I put let's say put what? Let's say if I want to note x equals to 1, right? The left hand side will be this. So it will become this n equals to 0 from infinity, and then I will get pn1 tn. So that's pn is 1 for all n. Second, if x is -1, then I will get 1 plus t. It's basically the negative term, negative to the power n. And then the same strategy. So I will get pn -1 is -1 to the power n. Okay, and so third one is always like people like to describe. So you put x equals 0, then you will get this one. So the left hand side will be this, right? If you put x equals 0 and there's no my 2xt terms. Okay, so this one is basically yeah, you can we can write it down as the binomial expansion. So for general n term is basically -n 1 3 5 to 2n -1 to 2n n factorial t 2n. Okay, and the least term, right? So basically this is summation pn 0 t 2n. Okay, so we notice that p2n plus 1 is 0 because there's no odd term here. Okay, but we got the p2n 0 is basically this one. So it's basically -1n 1 3 5 to n -1 to 2n n factorial, and change into, you can change into -n 2n factorial 2 to the 2n n factorial square. Okay, so this is this paragraph. Okay, so okay, that's it. Okay, the next paragraph is basically I want to discover the parity. Okay, so this is, I just want to ask that why pn x is even if n is even, if pn x is odd if n is odd. Okay, so proof. Okay, so this is also very stupid because that we know this one, right? We know this one. So if 1 replace x to -x, t to -t, then the rest, the left hand side is the same. Okay, so we have pn, right? So we just change the left hand side and right hand side. Compared to this side, we get pn x equals to pn -x times -2 power n. Okay, so done. Okay, so the third things I want to talk about is the upper bound, upper and the lower bound of pn cosine. So probably this is the most non-trivial things. Okay, so so what I want to do is that I want to give a bound pn cosine the absolute value to be less than something. Okay, so this is our goal. Yeah, just to find a bound for this c for n. Okay. So the starting point is like if I put let's say x equals to cosine, right, and this term will be right? So it's 1 minus cosine theta. Okay. So let's say one can write 2 cosine as the exponential, right? So I have this. So this becomes 1 minus exponential theta t, and then negative half, and then 1 plus exponential theta t. 1 minus exponential negative t, a half, negative a half. Okay, so this term can be expressed as 1 plus a half t exponential I theta 3a t squared to I theta. Also for this one, so it's 1 plus a half t, only change I theta to exponential negative 2I theta. Okay. So if you expand it, then you will get the a m. You see, so all of it is positive, right? So and you can combine it, and you will get something like this, some m, right? And the a m will be just positive. Okay, so this is the general Pn cosine. Okay, so now we can give a bound. Okay, so if one see the right hand side, we know that theta equal to 0 will be the maximum. So that means Pn cosine, right, will less than Pn cosine 0. Right? Pn where Pn cosine 0 is just Pn 1. Okay, and then we already proved that Pn 1 is 1. Okay, right. So now we have a theorem. We have a bound. Okay, so the theorem is that for all n, Pn cosine theta, the absolute value will less than 1. Okay, so this is our theorem, and I think that's for all the things that you need to know about Legendre polynomial. Basically, we already proved the recursion formula and the property. Okay, I will see you guys in the next video. Be sure to subscribe to my channel.